Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. And the question is wiggle subsequence. A wiggle subsequence is a sequence where the differences between successive numbers strictly alternate between positive and negative. The first difference may be either positive or negative. A sequence with one element and a sequence with two non-equal elements are trivially wiggle sequences. Okay, what does it says? Array with containing one element is also a wiggle sequence of length 1. An array containing two elements is also a wiggle sequence of length 2. Uh, Non-equal elements, okay, fine, non-equal elements. If it is equal, we cannot say it as a wiggle sequence because if it is equal, consider 2 comma 2, the difference comes out to be 0. It should not be 0, it should be either positive or negative alternative, strictly increasing. So we have to maintain the wiggle sequence order, so we cannot say take this length as 2. So here the length will be 1. Only we will be taking one element for this sequence. We will read further. For example, for consider this array. This array is a wiggle sequence because the differences is just we can find the differences between the adjacent elements. It is 7 minus 1 6, 4 minus 7 it is minus 3, 9 minus 4 it is 5, and 2 minus 9 it is minus 7, and 5 minus 2 it is 3. So as you can see here, there are alternative positive and negative and negative number, so we can say it as a wiggle sequence of length which is equal to 5, which is a so we should not take this length, we have to take this length, so the length will be 6. Hope you understand the problem. Check whether this is a wiggle sequence or not. Here the difference is 4 minus 1 it is 3, then 7 minus 4 it is minus 3, then 2 minus 7 it is 5, 2 minus 5 2 minus 7 it is minus 5. As you can see there, it is there violates the condition. We cannot say it as a wiggle sequence because after 3 it is a negative number, after minus 3 it should be a positive number. It should be strictly if following the order of alternative positive and negative. So we cannot take this as a wiggle sequence. This array we cannot take it as a wiggle sequence 1 4 7 2 5. Similarly for this array, as you can see 5 minus 5 which gives a 0, so we cannot say it as a wiggle sequence. So we have to find the subsequence is obtained by deleting some elements. We can set, they are given an array, we have to find some subsequence that maintains a wiggle sequence of longest wiggle subsequence. We can if we take this array, this whole array is gives a wiggle sequence, so we can say the whole array's length, which is 6, as the answer. But if we consider this array, let us see whether this is a wiggle sequence. This is 17 minus 1 it is 16, then 5 minus 17 which is minus 12, then 10 minus 5 which is 5, then 13 minus 10 it is minus 3, then 15 minus 13 it is minus 2. Here we cannot say it as a wiggle sequence. This whole array can't be wiggle sequence. So what we can say, we can omit this 15 and 13. So we can go for 10 minus 13. 10 minus 13 is minus 3. It is also not a wiggle sequence. We can check whether 5 is also not giving a wiggle sequence. 5 minus 13 is minus 8. So this is also not alternative. Then 16 minus 13 we can say it as 3. Then 8 minus 16 which is minus 8. So we are picking the elements 1, 17, then 5, then 10, then 13, then we are not picking 15, we are not picking 10, we are not picking 5, we are picking 16 here, then we are picking 8. So these are the elements that we are picking. These are the elements we are picking to give longest wiggle subsequence. So the array elements, the length of the array elements that we pick, which gives a wiggle sequence, is 1, 2, 3, 4, 5, 6, 7. So we have to maximize this. For this example too, this is the maximal answer. So we cannot get any other maximal answer. So we have to maximize the wiggle sequence length. That's the question. Hope you understood the question. So what we can do what we can do here is we can observe some of the cases. For given an element 1, 2, 3 and 1, 4, 2, 5, whether this is a wiggle sequence or not, we have to either pick this or not pick this. If we want to have a wiggle sequence in our array, we will surf through all the possibilities. We will go for all the possibilities and find the answer. If we go for all the possibilities, it will be basically n factorial ways. So here the time complexity will be coming for time complexity will be of n factorial, order of n factorial, for finding this answer if we go for all possible solutions. But we can try for doing that all possible solutions with the recursive approach. How we can go for it. For if we can consider this array as an indexes, each element as an index, we can take 1, 4, 2, 5 itself. We can consider this array elements as an index. We can say I am writing a recursive function which is going to start with an index 0. And I can say for whichever element I am going to choose, the previous element I can say it as any element, right? We can say that previous element to be 0, so that if we are going to pick this element 1 minus 0, we will be getting 1. If we are going to choose this 4 as a first starting element, then it is going to be 4 minus 0, it is 4. Then if we are going to choose this 2 as the element, it is going to be 2 minus 0, 2. 5 as the element, then 5 is going to be our starting point, then 5 as the 5 minus 0, 0. 5 minus 0, it is 5. So we can write a recursive function. We can express this array elements as indexes. It is going to start the index from 0. This will be going to give me, this recursive function is going to give me the maximum wiggle subsequence length, longest wiggle subsequence length of the array nums. So we need some previous element to compute. If we are taking this element 1, and then we are going to the next element, we cannot, we can either pick this element 4 or we can omit this element 4. Right, we can either pick this element 4 or we can omit this element 4 and we can go to the next index. So we have to, so for each time we have to know what is the previous element that we are going to pick. So to know the previous element that we are going to pick, we can say there is some previous index. Initially it is to be minus 1. We can say there is some previous index which is going to be initially minus 1. If I am going to pick this element, then my previous index becomes 0 and I will move to the next array element to pick either which element to pick. So that if I have picked 4 and I am going to omit this, if I have picked this 1, then I am going to omit this 4, then I am going to pick this 2, then I want to know whether this follows a wiggle sequence. To know this wiggle sequence, I want to find the difference of the with the current and the previous element. The current element is 2 and the previous element is 1. So we can say 2 minus 1, it is giving us 1. And previously we have 1 minus, if previously it has 1 minus 0, which is positive, and our wiggle sequence is always going to start via positive, and then secondly we are going to get our negative element. So how we can denote, how to denote the transition, that is changing to positive or negative. So we can maintain some flag pointer which is going to say whether I have to take a greater element or a lesser element. If currently you currently say it currently say I have taken this one, then next I have to take currently I have one, so next I have to take some greater element, right? I have to take some greater element, or I can take some lesser element. Let us say I am taking this 4. Let us say I am taking this 4. I can take next time, I can take either 2 or I can take either 5. But I am not going to take this 5 because already I have a positive difference. So I will be taking this 5 minus 4 as it will be coming as 1. So I cannot take this element because this will not give me a wiggle sequence, right? So what I will be doing is maintain a flag pointer. Maintain a flag which tells me the tells me whether we should take greater or lesser element with difference, or we can say whether it is alternating. So this flag was going to maintain the alternative fashion of this wiggle sequence flag. So since we have to take all the possible ways, we have to have two flags, right? Either it should be I should find from true, or I should find from false. I should not miss out any of the cases, right? So I will be taking this, I will be calling these two functions, and I will return the option. This will be my option 1 and this will be my option 2, and I will be returning the maximum of both the options. So this is my recursive function calls that I am going to make. Now we will see what are the cases. First, if my previous index is coming to be 1, what I can do? If my previous index is 1, what I shall do? I can pick the current element. That is going to be my start point, right? If I have given the array as 1, 4, 2, 5, and I am going to call this function from this values 0, -1, true. Then what I can say is, if my previous index is 1, then this is the first element that I'm going to pick, or this is the first element I'm going to pick, or this is the first element I'm going to pick. So what I can say is, I can have some one variable option 1 which is going which I'm going to pick 1 plus I'm going to call the next I'm going to call the function with next index I plus 1. I have picked this element, current element. I will just start with this return. I am going to start with this element. I will be moving to the next element I plus 1. Then my current element current index I becomes my previous index. Then since I have taken the this value 1, then I want to toggle it. Next I want to find negative difference. So I will be toggling this flag. Since I am picking this element, then I am going to toggle. Or else what I can do? Correct. This will be my case 1. If my previous index is 1, then nothing but I'm going to start the subsequence with either 1, either 4, either 2, either 5. So I'm going to pick the current element, then I'm going to move to the next element. If I move into the next element I plus 1, then my current element, current index becomes my previous index. So I will be passing it, and I will since I have taken one element, then I have to toggle the flag. I can either pick or not pick. Fine. Now I'm coming to the else part. What if I have chosen one element? Consider I have chosen this one, first element 1. Next I will be coming to the function call with function call say solve of 0 plus 1, it is 1. Next I will be 0, the previous index is 0, and flag is initially consider I am calling with this function true, so it will be toggled, so I will be going with false. So this will be the function call if I'm going to pick this element 1. Right. So I will be coming to the else part. Now I have either two conditions. Either my flag will be true or my flag will be false. What indicates the flag is true? If my flag is true, then I have to, then what I want to see is if my difference, I'm getting a difference which is greater than 0. It should be positive or negative, positive, negative, right? It should be in alternative function, alternative fashion. So I will calculate my difference. In difference, what is my difference? Current element minus my previous element. Current element I will get in my nums of I, minus my previous element is nothing but nums of previous index. Nums of I minus nums of previous index gives me the difference. If my flag is true, then what I can check is if my difference is going to be greater than 0, then I will have another one option, which is since it is going to be alternative, I am adding one length. I am adding the subsequence length as 1, and I am going to the next function call with I plus 1. Since I am choosing this current element, I can either pick this element or not pick this element. Since I am picking this element, I will go move to the next index I plus 1, and my current index becomes my previous index in my next function call, and then yeah, my flag will be toggled, right? Or else I don't want to pick this element. If I'm not picking this element, it is option I will, since I will make it as option 2 and it is option 3. Okay, fine. mm, Here I have already the variable option 1, so I will declare this as option 2 and I will declare this as option 3. Since if my flag is true and my difference is greater than 0, so I am considering I am picking this element. If my difference is greater than 0, I am considering I have picked this element. I am going to move to the next index, and I will say this current index becomes my previous index for my next function call. Or else I don't want to pick this element. If I don't want to pick this element, then I don't want to add one extra length to my next function call. So I can do it as 0 plus solve of. I will be moving to the next index, and my previous index stays at the same index itself, same before index itself, and the flag is not going to be toggled. Similar way, I am going to reverse this, vice versa. I am going to reverse this, and I am going to paste here if my flag is false. If my flag is false, then I should be checking whether the difference is less than 0. If my flag is less than 0, then I can say my option 2 is 1 plus solve of, I am going to my next index I plus 1 and I am toggling the flag pointer. Or else I can calculate the option 3. Since I'm not picking the current element, then it is 0 plus solve of I plus 1. The previous index stays at the same point, and then I will not toggle the flag, and I will pass the flag pointer itself. And after this if else, what I can say is I can just return maximum of both option 1, option 2 and option 3. Since here I am returning itself, I will say I don't want to declare any variable here, so I will say the maximum of option 2 and option 3 is going to be my maximum optimal answer. This is going to call for every index, and this will take all possibilities. So here the time complexity will be order of 2 power n. It is going to be grow exponentially. So how we can just code this recursive approach. This is a recursive approach. We can try coding this first. So I will copy and paste this code that like given in my function call. So I said I will be making a function which is solve, and int option 1 which is going to call the solve method from nums and 0th index. Then I should pass the previous index is -1. Then I should pass a flag true. I should take for both conditions. So I will say solve nums 0th index I'm going to start, -1 will be my previous index, and false, and I will return maximum of both the options. So this is my recursive functions that I have defined. Now I will define the recursive function solve vector int nums. This is my index I in previous index, and this is my flag variable. Okay, fine, super. Then we can just paste the cases. These are the cases that I have explained you. Hope you got some understanding here. We'll try to do a dry run once again. What will be my base case? This will be my base case. If my I is going to reach my last last element of the array, then I will return as 0, or else I will be doing this, right? Or else if my previous index is -1, then I will be adding 1 to my answer, and I will be calling the function call with next index I plus 1, and I can either take I can pass the I as my previous index for my next function call, and the flag variable nums will be passed here. Nums will be passed here, nums and nums, here 2 nums. Okay, fine. Okay, if my previous index is -1, this is what I'm going to return. If my previous index is not -1, then I can calculate the difference. And if I'm saying if my flag is true, if my difference is greater than 0, then what I can say is my option 2. I will declare initially option 2 to be 0 and option 3 to be 0. Or else this is going to be my option 1. This is going to be my option 1. So I will be calculating, I will be picking this element. This is my picking condition. This is my picking condition. Pick condition and not pick. Not pick. Similarly, this is my pick condition and this is my not pick. Hope you understand. And I will return maximum. Okay, fine. So this will be my recursive function, and hope you understand. Since I will be calculating for both true and false, I will be validating all the possible ways. So all possibilities. So here the time complexity will grow exponentially. We can just run the code whether it is getting accepted for our sample test cases. Okay, private test code. It got accepted. We will use the example test cases as well. It got accepted. So here we have written a recursive approach, but this is not obvious. This is obviously not going to work since the constraints is even 1000. It is going to grow exponentially. We will be getting time limit exceeded. Since we will get time limit exceeded, we will try to optimize this. We can do since it is a recursive approach, we can do dynamic programming and we can memoize it. We can do memoization in this. So let us see what is the changing parameters. The changing parameters is I, previous index and flag. So we will declare a three-dimensional array. We will declare a three-dimensional array. I will say it I will name it as dp, and the changing parameters is I. What is the maximum value of I? Here the constraints nums.length is 1000. So the maximum value it can go is 1000. So I will 1001, 0 to 1000. So what is the previous index? Previous index is nothing but 1000. So it will also go till 1000. So I will name I will give 1001. And what is bool flag? There will be only two cases. Only two, either 0 or 1. So I will give the array size as 2. So I have declared a dp. Before passing the before calling the functions, I will initialize the dp with -1. I will use memset for it. So I have initialized it. Initialized all the elements in dp to -1. So this will be my dp. Now we have to memoize it. How we can memoize it? Since it is public, since this is outer, so we don't want to pass in function calls, we can directly do it. How we can memoize it? We have to check whether dp of I, previous index and flag is not -1, then not -1, then obviously I can return dp of I, previous index and flag. Correct? Yeah, absolutely correct. So it is dp of I, previous index, flag. But what if previous index is -1? If my previous index is -1, I cannot access dp of I something as -1, right? We cannot access the negative index. Okay, now if my previous index is -1, I cannot access the negative index in my array. So if my previous index is not -1 alone, then I will be checking this condition whether the dp of I, previous index, flag is not -1. Okay, solved. Then we have to cache it. How we can cache it? We can just say dp of I, previous index, then flag equals to max of my option 2 comma option 3. Now we can just run the code and see whether it is running, whether it is getting accepted. It should get accepted. So the time complexity here will be, what will be the time complexity here? It will be, we are using a three-dimensional, the time complexity will be order of n's. The order of n into n, and the space complexity will be order of n into n into 2. Okay, fine. So we can just try to submit our code. It got accepted. Hope you like this approach, and we have just tried a recursive approach, then we have memoized it, and it is a dynamic programming problem. Hope you understood it. Let us see in tomorrow's daily challenge. Until then, bye.